Everyone, in this lesson, we are going to do the rest of 3.3, which is about graphing using intercepts. So I just wanted to take a moment first, though, to show you the different lessons that are going to be in Unit 3, which is all about graphing linear equations. And I mentioned this in class, so for the e-learners, make sure that for this unit, you start using your graphing notebook to take notes. So get out your graphing notebooks. That way, when you are going to need a graph, which will be quite often in this lesson, and in these lessons, it's right in front of you, okay? If you don't have a graphing notebook, make sure you go out and get one as soon as possible. So for the next couple lessons, 3.1 and 3.2, we are actually going to skip this because plotting points in a coordinate plane and graphing linear equations, we are going to just incorporate that into these next lessons. And you already did plot points in the coordinate plane when you were doing the Khan Academy. So graphing using intercepts, this is also about your horizontal and vertical lines, which you did yesterday. And then 3.4 is about finding the slope and the rate of change. So you already got some practice with that, and we'll do several more examples and look at slope and in terms of rate of change in real world setting, and then graphing using slope-intercept form, which is y equals mx plus b. So that's something we've already seen a few times, and we're just going to be working with it more with graphing, and then graphing linear functions of all different types, okay? So that's what we're heading into. It's a relatively short chapter, but the concepts in this lesson are super important for the rest of the year. So you want to really make sure that you're watching the lessons carefully and not just rushing through it and really thinking about what you're learning. So horizontal and vertical lines, we already did this yesterday. So why is horizontal and vertical lines in the same lesson as graphing using intercepts? Well, if you remember from the lesson, a horizontal line, so say I draw an x and y axis. So this is the y-axis. This is the x-axis. So a horizontal line, I'll do in green, goes from left to right. I think about like a horizontal hug. So like you're reaching your arms wide like a horizontal line. So a horizontal line crosses through only the y-axis. So it has a y-intercept. So a y-intercept. And then let's do vertical in red. So vertical, like a vertical V. And the V goes kind of like up and down. So that's how you can remember that. Vertical V, like if you put your arms up as a V, then you're putting your arms up and down, and that would be a vertical line going up and down. So a vertical line is the opposite, and it goes through the x-axis at a certain point. So it has only an x-intercept. So for example, the equation of this line would be x equals whatever it passes through on the x-axis. Say, for example, this is -4. And then the horizontal lines go through the y-axis, and they have a y-intercept, and that would determine what the equation is. So say this is 2. So this equation of this line would be y equals 2. So a horizontal line doesn't have an x in it, and a vertical line doesn't have a y in it. It's just x equals whatever passes through on the x-axis, y equals whatever passes through on the y-axis. So that's why we prefaced this lesson of using intercepts with horizontal and vertical lines, because they are the prime example of equations that pass through the x and y axis, and their intercept determines what the equation of the line is. So let's get to today's examples. All right, so part 2, graphing linear equations using intercepts. So make sure you write down these two boxes here. So the first thing we're going to talk about is the standard form of a line. So standard form is when the x and y are on the same side of the equation, and then the constant c is on the other side. Capital A and capital B just represent the coefficients. Okay, so a and b are coefficients, And then C is a constant, which is a number just by itself, not multiplied by a variable. Okay, so here's an example. 2x plus 7y equals 28. That's actually the first example that we're going to see. So in order to find, so that's about standard form. Over here, the definition of intercepts. So you already looked at this in a Khan Academy assignment. So you've got your y-intercept and your x-intercept. The y-intercept is where the graph crosses the y-axis. The x-intercept is where the line crosses through the x-axis. Anytime you are going to label anytime you name a y-intercept, the x is always 0, and the y is always whatever it crosses. Opposite for an x-intercept. So the x is where it crosses, and the y is going to be 0. So they're opposite. So for an x-intercept, the y is 0. For a y-intercept, the x is 0. So the x-intercept of a straight line, and all lines are straight, you guys. So just take a note of that. If it's not straight, then it's not a line. So all lines are straight. But this specifically would be what we would call a slanted line rather than horizontal or vertical. So every slanted line, whether it has a positive slope or a negative slope, has two intercepts, an x-intercept and a y-intercept. But if it's a horizontal or vertical line, then it only has one intercept. So anyways, is the x-coordinate of the point where the graph crosses the x-axis. The y-intercept of a straight line is the y-coordinate of the point where the graph crosses the y-axis. Okay, so let's say that this is 1, 2, 3. So the y-intercept would be 0, 3. Let's say that this is also 1, 2, 3. So the x-intercept would be 3, 0. So you should be familiar with that from the Khan Academy assignment. So let's do some practice with actually how to determine the x and y-intercepts. So in order to find, let's start with the x-intercept. So in order to find an x-intercept, make sure you write down the steps. You set the y equal to 0. Because remember, back here, the x-intercept, the y is 0. So in order to figure out what the x is when y is 0, we just make y 0. So if you were to make y equal to 0 in this equation here, 7 times 0 would just be 0. So this would cancel out. So then you're left with 2x equals 28. So then x is 14. So then you would write it as a coordinate, 14, 0. All right, now let's do the y-intercept. So the y-intercept is the opposite. You set the x equal to 0 because the y-intercept is when x is equal to 0. So basically, as we saw from the x-intercept, when you want to find an intercept, you just cover up the other variable. So here, if we want to find the y-intercept, we just cover up the x. So scribble out the x. Be careful to not scribble out the sign that goes with the other variable. So this is a plus sign. So then you're left with 7y equals 28, which means y is 4. So the y-intercept is 0, 4. So these are your two answers for the x-intercept and the y-intercept. If you just leave your intercept as a number, you will get points marked off because the definition of an intercept is a coordinate. So you have to write your answer as a coordinate. All right, let's do this for part B. Let's find the x-intercept by setting the y equal to 0. So if you set the y equal to 0, that cancels out, and you get 3x equals 6. So x is 2, which makes a coordinate of 2, 0 for the x-intercept. And then we'll do the opposite for the y-intercept. Set the x equal to 0. So you have 2y equals 6. Y is 3, which means the y-intercept is 0, 3. Okay, so remember, whatever you're left with, so if y is equal to 3, then that goes in the y-coordinate, and then the other one is 0. Never would you put these two coordinates together. They're two separate coordinates, only related to each other 5 the line, but don't put them together as like 2, 3. That would not be correct. All right, let's do another example. So here, you have 4x minus 2y equals 10. So to find the x-intercept, cover up the y. So that would get rid of that term, and we're left with 4x is 10. So x is 10 over 4, which is equal to 5 halves. So then the x-coordinate would be 5 halves, comma 0. 2.5 is okay. You can write it as 2.5. However, one thing to note, so for example, if we got like 5/3, that would come out as a repeating decimal. So if you get your answer as a repeating decimal, then that means just leave it as a fraction. So we don't really want repeating decimals when we're writing coordinates. Okay. And then the y-intercept. There will be a time and place for repeating decimals when writing coordinates, but for now, just leave it as a fraction. So to find the y-intercept, you will cover up the x. So this is where you need to be careful because what's left is negative 2y equals 10. Can't forget about the negative sign, or else you'll get a point off. Divide by negative 2. You get y equals negative 5. So notice I carried the negative sign over when I divided. So then the coordinate would be 0, negative 5. So those would be your 2 intercepts. Now, let's say we wanted to graph, for example, this problem from part B. So if I wanted to graph this equation, I had a coordinate plane here. You could do this for all of your examples if you want, but we'll graph the x and y intercept. So the x-intercept was 2, 0. And then the y-intercept is 0, 3. And then you would take whatever straight edge you have and draw a line through them. Just like that. Okay, so that's what the line would look like. And this is why you want to use graph paper, because notice that my ticks here are not really spaced out evenly, so it's very helpful to have, well, it's necessary to have a coordinate plane, especially when we get into problems where we're trying to look for where 2 lines intersect, for example. We don't want to mess up that just because our ticks are not equal. So anyways, part D, I'm going to let you try that one by yourself. Okay, so pause the video and try it yourself. And then now I'm going to go ahead and show you how to find it real quick. So for the x-intercept, cover up the 5y, you get negative 3x equals negative 15. Divide by negative 3, you get 5. So that would be 5, 0. The negatives would cancel out since you're dividing a negative by another negative. For the y-intercept, it would be 5y equals negative 15. So y is equal to negative 3. The negative stays because you only have one negative. And that coordinate would be 0, negative 3. Okay, so that's how you get the answer to part D. All right. So now we're going to graph the equations that we found in part 1. So for A, what we did here, then find the slope of each line. Sorry, I was getting mixed up with the directions. So first we're going to graph, and then we're going to find the slope of the lines. So for part A, let me just recall the points. You can look back in your notes to get the points. I'm just going to look back in my paper. So the points were, actually we're going to skip A because graphing A because that one was 14, 0, and my graph doesn't code to 14, but you can go ahead and graph it if you want. I'm just going to go ahead and find the slope. So to find the slope of that line, we would just need the 2 points And we would need to recall the slope formula, which is y2 minus y1 over x2 minus x1. So this would be, the y2 minus y1 would be 4 minus 0. X2 minus x1 would be 0 minus 14. So this would simplify to 4 over negative 14, which would be simplified to negative 2/7. And if there's just one negative sign, then you can pull it out in front. If there were two negative signs, then they would cancel. Okay, so that's the slope for part A. All right, I'm going to erase this just because you should have it written down now, and if you don't, you can just scroll backwards in the video, rewind, whatever that's called. And let's look at part B. So for part B, the intercepts were 2, 0, and 0, 3. So I guess I got ahead of myself when I was talking about the graphing. So let's plot these two intercepts. So 2, 0 would be the x-intercept, 0, 3 is the y-intercept, and then you would take your straight edge and draw a line through them. Please make sure that you are using a straight edge, a ruler, your ID badge, protractor, straight edge, whatever you have. And then all lines have arrows at the ends, so you would make arrows. Right, and then let's find the slope. So the slope of, I'm just going to say the slope of line B, so M sub B would be y2 minus y1, so 3 minus 0, over 0 minus 2. This would be 3 over negative 2, which you could just leave like that, or you can write it as negative 3/2. All right, part C. For C, our points were 5/2, 0, and 0, negative 5. So let's plot the points. So 5/2 is 2.5, and then 0, negative 5. Draw a line through them. I'm just going to extend this line backwards a little bit, and then make arrows. All right, let's now find the slope of line C, M sub C. So we have negative 5 minus 0 over 0 minus, I'm just going to call this 2.5. So we get negative 5 over negative 2.5. So first of all, the negatives cancel, so we can cancel those out. 5 divided by 2.5 is just 2. So the slope would be 2 for that line. All right, and then for the last one, we're going to do this one in green. The points were 5, 0, and 0, negative 3. So 5, 0, 0, negative 3. Draw a straight line through them. And find the slope. So the slope would be negative 3 minus 0, y2 minus y1, over 0 minus 5, and that would be negative 3 over negative 5, negatives cancel, and you get 3/5. So 3/5 would be the slope for line D. Okay, so the rest of the questions for this lesson are word problems. So we're actually just going to go ahead and dedicate a whole day to word problems when you come back next week. So you don't have to worry about those word problems quite yet. Let's just understand just this basic concept of finding the intercepts of a regular line, graphing, and finding the slope of it. All right, so as long as you know the x and y intercepts of a line, you can find the slope of a line. All you need to find the slope of a line, all you need is just 2 points. And if you have an x-intercept and a y-intercept, those would count as 2 points, and you could use the slope formula to find the slope for them. And just so you know, the other way you can find a slope of a line is rise over run. So let's take a moment to go back to line B. And if we go from this point to this point, always go from a point on the left to the point on the right, like you're reading a book. You would rise down -3 and to the right 2. So we get the slope of -3/2, which is exactly what it was over here. So you can also use rise over run. So for example, line D, you would go up 3 over 5. For the red line, you would go up 5 over 2.5, which we determined was 2. Okay, so you can also use just the graph placement instead of the slope formula. Okay, whatever you find easier or more convenient at the time. All right, so that concludes this lesson. I hope you guys have a great day.